Good evening, everyone. It's a pleasure to be here. Today, we are diving into a topic that not only touches on sustainable energy, but also we imagines how we can turn waste into something valuable. I'm Kusifren, representing Group 2, with my co-members Mensa Kwabena Oponbiu and Odum Sonia Atremansa. And I'm excited to walk you through this project on the production of methanol from sawdust. As the world moves towards a more sustainable and environmental friendly alternative to conventional fossil fuels, the use of biofuel and bio-based chemicals is one of the most discussed alternatives. Methanol is an organic chemical compound with a molecular formula CH3OH. That's a methyl group bonded to a hydroxyl group. Methanol is a very crucial commodity in the modern industry due to its versatile nature. Methanol is primarily used as a building block and precursor for other chemicals, including formaldehyde, acetic acid, dimethyl ether, and others. Methanol is also used as a solvent in paints. Methanol is used as fuel. Methanol can also be used as an antifreeze in pipelines and other industrial applications. Methanol is also used in chromatography and spectroscopy. One may ask, how is this methanol produced in the environmental friendly manner? Methanol is produced this way through the catalytic reaction of syngas, which mainly consists of carbon monoxide, carbon dioxide, and hydrogen gas, which is obtained from sawdust, our main raw material. This is the stage-to-stage process that the sawdust goes through to produce the methanol. Sawdust is first treated by reducing its size to enhance its surface area for effective work of the catalyst. It's also dried to reduce its moisture content, also for effective work of the catalyst. Now the treated sawdust is then placed in the gasifier over a nickel-based catalyst to convert it into syngas. Now, this syngas, the precursor for methanol, is then cleaned and conditioned to remove tars and other impurities. The cleaned gas is then placed in a methanol reactor, most likely a fixed bed methanol reactor, over a copper-based catalyst. And then the syngas is then converted into methanol. Methanol collected is then collected and purified to attain a very high concentration of methanol as the end product. This is the plant setup of the plant the plant setup for the production of methanol. Now in this plant setup, the sawdust is fed here, it is crushed, it is dried, it is crushed again, and then placed in the sawdust feed. It is then sent into the gasifier where there is a nickel-based catalyst to produce the syngas. Now the syngas is then cleaned in this area, and the clean syngas is then fed into the methanol reactor to synthesize the methanol over a copper-based catalyst. Now the product then contains liquid and gas. It is then separated in this area, and then the methanol is first stored in the methanol tower and then later in the methanol storage tank. This is how methanol is basically produced at the industrial level. At a methanol production company site, this is how you expect the place to be planned. The administration, that's the break room, the help desk, cafeteria for the workers, the employees. Then the laboratory testing area, prototyping area, the operations unit with a control room very close to it and then a bit elevated to be able to monitor the operations in the operations unit, the storage area that contains the storage tanks, and then the track of flooding and the parking area. Our computer is needed now in almost every aspect of our life, and it's the same in the production of methanol from biomass. They are devices that needed to collect data from the plant environment and send it to the central computer system for processing, monitoring, and control. Some of these devices are the thermocouples, the pressure sensors, the flow meters, level sensors, face recognition scanners, and then conductivity sensors. Some of the output devices that will be needed to give feedback and then display process data to plant operators and workers include the monitor, indicator lights, alarms that will indicate or signal the workers, printers, and then display boards. The computer will need software or softwares for the efficient and then effective production of methanol. Some of the softwares will process simulation softwares, day-to-day control softwares, cybersecurity softwares. Some of the process simulation and modeling softwares include the Aspen Plus, MATLAB, ChemCAD, and then for the day-to-day control, you will need Ignition and then Aspen MBO. Then for the cybersecurity aspect, Fortinet, FortiGate, RAG series or Fix will be a very good option. Now, the network connectivity of the entire company will be a wired local area network. A wide local area network. This majority of the setup in the processing site will be, as I said, a wide local area network, and then there will be some wireless connections that will be used in areas where it is hard to run cables. Now, the LAN is the best is the best choice because it provides speed, stability, and then it also helps connect all the areas of the industry or the company. Now the network topology will be a star topology, and then this star topology allows expansion. Now each connection will be independent, and then troubleshooting will be very easy. Star topology is simply the best option for this processing site. All in all, the production of methanol from biomass, specifically sawdust, provides a promising approach to a sustainable and environmental friendly alternative to fossil fuels. Producing methanol from biomass offers multiple advantages. It can help diversify energy sources, reduce reliance on fossil fuels, and address waste management issues by converting biomass into a valuable energy carrier and chemical feedstock. Thank you for your time and for your attention.